giving an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. So as you see in this example, this is the array is given to us. We are supposed to move all the non-zero elements to the beginning of the array and zero elements to the end of the array, and we should keep the relative order of the non-zero elements. So if we have 1, 3, 12 here, we should have 1, 3, 12 here too. So basically we have two things that we should follow. First, we should move the zeros to the end of the array. Second, we should keep the order. We should also do it in place without using any extra space. And let's see how we can do that. When we talk about like moving elements around, what we can think of that make it efficient and we can do it in just one iteration is using pointers. As we are keeping track of the zero elements and non-zero elements, we can use two pointers, pointer I and pointer J, and we are going to make these pointers pointing at the first index of the array, which is going to be index 0. So let me write an example here. So here is the case that we are going to have, right? So we are going to have a pointer J and we are going to have pointer I. The pointer I is going to keep track of non-zero element, and J is going to keep track of zero elements that we need to swap them around. So what we're going to do, we are going to have a for loop for I for non-zero elements over the array. We are going to length nums, we are going to iterate over all the elements of the array, and then what we're going to do, we are going to see if the value that we have in nums I is not equal to 0. Because if it is not equal to 0, then it's time that we can swap them around. And what we are going to do, we are going to swap nums I and nums J and nums J and nums I. Because as I mentioned, I is keeping track of non-zero elements and J is keeping track of zero elements. So let's go through this example, and then we are going to +1, and then we are going to return nums because we are doing it in place. Let's go through an example and see how this code works. So we start from index 0, I is pointing to 0, J is pointing at index 0, which we have value 0 in it. So then we are going to say if I is not 0, then we are going to do this. But look at this, I is 0. So what we are going to do, we are just going to move I forward. Now we are going to check if I is not pointing to 0. I is not pointing to 0 now. So what we are going to do, we are going to swap these two elements. So now it is going to be 1, 0, 0, 3, 4, right? And then we are going to move J one step forward, which is going to point at index 1, and we are going to move I one step forward too. And then we are going to check if I has 0 in it. If it does, we do nothing. But if it doesn't, we are going to move this one step forward. And then, as you see, now I is not equal to 0. It's not pointing to 0. So what we are going to do, we are going to swap the value that we have in I with the value that we have in J. So we are going to have 3 here, and we are going to have 0 here. Then we are going to move J one step forward, and then we go through if, and we are going to move I one step forward as well. So now this condition is valid. The value that we have in I is not equal to 0. What we are going to do, we are going to swap the value that we have in I and J. So 4 is going to be here, and 0 is going to be here, and J is going to one step forward. And because the like iteration over the array is over, we are going to return the result. As you see, it's going to be 13400. So the space complexity is going to be constant, and the time complexity is going to be linear, ON, because we have to iterate over the array. Let's go try another example and see what if like it wasn't starting with 0. So it was something like 1, 3, 0, 5, and 6. How was for this case? So as you see, we start from index 0 for I, and it start from index 0 for j, right? And we check if the nums that we have in I is not 0, we are going to swap I and j. But because they are both pointing at the same thing, what will happen? It's gonna stay at the same place. We are going to move j one step forward, one step forward for I. And the same thing, it is valid, but we are going to swap on I and j at the same index, which is going to be kind of no move. So we're going to move one step forward, and j is going one step forward. And then you see I is equal to 0, so we are going to move this one step forward, and then we are going to see 5 is here, so this if is valid, so we are going to flip this, swap this with this, and we are going to move one step forward, one step forward. As you see, j is keep tracking of zeros, and I is keep tracking of non-zeros, right? And let's run the code. You can see it works perfectly. Thank you.